Okay, class. Last class we had gone through the data collection for Newton's second law of motion. And today I said that we would have the opportunity to work through the data and actually be able to finish the lab. And after you finish the lab today, then there will be a review guide for our unit test that'll be posted in Canvas as well. So, just as a review, we had our cart and we had some amount of mass in the cart. Okay, and then we took our hanging mass off the side of the desk, and this became a force of gravity, but downward. But due to the pulley, we redirected that to a horizontal force to pull the cart across a distance here. And my diagram here says 1.2 meters. However, in lab from the other day, it was somewhat shorter than 1.2 meters, as our lab benches are a little bit short. So, a couple of things. I took data from the lab, and if you're absent and missing data, or let's say you didn't quite get all the way done with the data, you can use my data for today to finish the lab. But the big thing, we'll need to make sure that we're calculating all of these things right. So first of all, average time, right? And we started this in most of the classes last class, but if your group was a little slow in gathering the data, remember, we want to take an average of the two numbers, which means that we're going to have to add these two numbers together and then divide by the number of numbers that went into the problem. So like, if I'm going to take a look here and averaging these two, I'm going to add 0.86 seconds plus 1.13 seconds and divide that answer by 2, which gives me 0.995. Okay, so when you're finding your average times, we'll need to do that. Now, the average distances, or sorry, the average speed is going to be the distance. Remember, a speed is, especially an average speed, is the total distance divided by the time it took to travel that distance. And so here in our lab, you should have a distance here to plug in, and you will need to show one example calculation of how you are calculating your speeds down here. The speeds, and we'll need to show the example calculation because on a lab, any of our calculations that are using and analyzing data, we need to show one example calculation. We're going to assume that the rest of those are calculated. So, for example, in my data that I have made up here, I have 1.2 for the distance and dividing it by my average time. Then this here would be 1.21 meters per second. Okay. So in both our data tables here and here, we're going to need to find the average speed and average times. Now, when we come down to this bottom data table, and we'll do one example calculation completely together, then we're trying to find acceleration in this table. Okay, in our lab, we don't have an initial and final speed. We have an average speed. And so we'll need to be able to find the acceleration using Newton's second law. And Newton's second law says that the acceleration of an object is equal to the net force acting on the object divided by the mass of the object. So here, I do know the mass of the cart. Here, the cart that I massed was 99.7 grams. And I know that I had a mass inside of the cart here at 500 grams or 1,000 grams if I'm in the bottom data table. And so my mass is going to be the 99.7 grams plus the 500 grams, which equals 599.7 grams. Now, if your mass of the cart is a little larger or a little smaller, that's okay. The carts have different masses, but the important thing is when we plug it into Newton's second law, we need to make sure that our mass is in kilograms, because a Newton divided by a kilogram is equal to a meter per second squared, not a Newton divided by a gram. So we need to convert, and remember, if I wanted to use a conversion factor, grams would go on bottom, kilograms would go on top. We know 1 kilograms in 1,000 grams. And so here, the mass is going to be 599.7 divided by 1,000, which is 0.5997 kilograms. Now, each of the columns up here in our data table has a different force, right? Either 0.5 newtons, 1 newton, or 1.5 newtons. And so I'm just going to choose to fill in here and see what the force of 0.5 newtons does. And so here our acceleration is the 0.5 newtons acting on the cart, pulling the cart divided by the cart's mass in kilograms, 0.5997 kilograms. And so 0.5 divided by the 0.5997 is 0.83 meters per second squared. That's a rounded answer, but that's what we'll put into the chart then. So I'm going to continue to solve for accelerations in this column using my mass of 0.997 kilograms, and the mass here is going to be a little bit different because it's the 1,000 grams in the cart, but you're going to follow the same process. Remember, the force changes in each column. So after that, you guys should be able to go on to the back side and actually fill out the data table. Couple of notes for the data table. Make sure you put a title, axis labels, a scale on each label, and make it a line graph. And so on here, we're graphing our average speed on the y-axis and average time on the x-axis. So be sure to include your labels with units, the scale, make an appropriate scale. I don't want all the entire thing to be all in one little corner. And we'll be able to turn this in. Again, after you submit to the Newton's second law lab, there will be a study guide for our unit test that will be posted in our module for forces in motion. Email me if you have any issues, and I'll get back to you quickly.